We now finished learning workbook page 180. Let's do one more problem of this type where we are plotting points, drawing the asymptote, and then clicking the button that connects the points together for us. Because we've already done two problems of this type, I'm going to move more quickly through this third one. Graph the exponential function f of x equals negative 3 to the negative x. To graph the function, plot the points on the graph with x values specified here, draw the asymptote, and click on the graph button. All right, once again, we're going to have that ask yourself the question. Ready? Taking a look at this equation, what's the base? What do you think? If you said negative 3, you are wrong. If you said 3, you are right. Now, why is it just 3? Well, because this little hyphen is mathematical shorthand for -1 times. And what happens first in the order of operations? Is it exponents or multiplication? The answer is exponents. This would be done first, then you would multiply by the -1. So we can see here that the base of the exponential expression is 3. That's going to be important for us to remember. The base is 3. The base is 3. All right, great. So let's use the method specified. We're going to plug in each of the x values one at a time. All right, if x equals -2, then y equals -3 to the -2. You have to be very, very careful here. One of the negatives comes from the equation. The other negative comes from the value of x. All right, now we know that a negative is a positive, so we get -3 squared. We follow order of operations, and we figure out what this is first, then make it negative. Well, 3 squared is 9, so make that -9 is the result that we get. All right, next one. If x equals -1, then y equals -3 to the -1, which is -3 to the first power, which is -3. All right, if x equals 0, then y equals -3 to the -0. Now, there's no such thing as -0. It's just 0. And following order of operations, we do 3 to the 0 first, which is 1, then make it negative. So we get -1. All right, 2 more left to go. If x equals 1, then y equals -3 to the -1. All right, we have to do this first. So we get -1/3 to the +1, which is -1/3. And finally, if x equals 2, then y equals -3 to the -2. Do this first, so we get -1/3 squared, -1/9. Okay, great. We've got all 5 points. How about the asymptote? Well, just like the last problem, the asymptote is the x-axis. Why? Because our parent function is 3 to the x power, and the only transformations we observe here are 2 reflections. Reflections do not change the location of a horizontal asymptote, so our asymptote for this problem is the x-axis. All right, so now we're ready to finish this problem. Let's go ahead and create our graph. All of our y's are negative, so I'm going to make my graph look like this. I'm going to emphasize quadrants 3 and 4. I need to go all the way down to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I should say all the way down to -9, pardon me. Okay, great. Let's plot some points. Here we go. Do this in green because, you know, why not? All right, -9, -2, -9 would be this point right here. -1, -3 would be here. 0, -1 would be here. 1, -1/3 would be here. 2, -1/9 would be here. And we play a game of connect the dots. And we remember that these are approaching the x-axis as our horizontal asymptote. I will draw that in here with a red dashed line. This is the location of our horizontal asymptote, which we are approaching. And there we go. We put in our 5 dots, we put in our horizontal asymptote, we connect the dots together, and we have our answer.